discuss the MCQ paper, right? Okay. Right, let's start with the first one. Right, the first question of MCQ paper. The scientist who is not related with the hydrogen spectrum is Balmer is there, Seaman is there, Pauling, Lyman and Bohr. Right, definitely Balmer is related to the Balmer series, right? He is the scientist who discovered the Balmer series, right? Then Lyman is the one who came up with the Lyman series, right? And then Niels Bohr is the one who gave a complete description how the about how the lines are to occur, right? With the use of the engineer diagram of the hydrogen atom, right? So Niels Bohr is the one totally described the appearance of the hydrogen spectrum, right? With the use of hydrogen engineer diagrams, right? So he is also related there, right? So we have two guys, Peter Seaman and the Linus Pauling, right? So if you have to think of the Seaman's contribution towards the spectrum, right? So when it comes to hydrogen spectrum, this is the question number 1, right? Right, if you are to examine the hydrogen spectrum, right, with the external magnetic field or with the external electric field, right, they have seen that, right, these lines are fitted to few spectral lines, right, like this. One line is actually a combination of few lines. Such kind of thing has been observed when they have done the experiment in external electric fields as well as magnetic fields, right? This thing is referred to as the Seaman's effect as well as the that is basically Seaman's effect, right? So Seaman effect and the Stark effect. Fitting of spectral lines in the presence of electric or magnetic field. Fitting of spectral lines to few lines, right, in electric and magnetic fields. Seaman and Stark effect, right? So Peter Seaman is the one which came up with the Seaman effect, right? So Seaman is with kind of a contribution, right, towards the hydrogen spectrum there, the Seaman's effect, right? So the answer is going to be the Linus Pauling. Linus Pauling is the one which introduced the Pauling scale, right, of relativity, right? So answer is Lyman Pauling, right? Linus Pauling, right? Linus Pauling. Only came up with the Pauling scale. Of electricity values. He has nothing to do with the hydrogen spectrum, right? So the answer is answer number 3. The answer is answer number 3. So the question number 1, right now? Okay, then let's come up with the question number 2, right? Question number 2. See what it says. The correct increasing order of first ionization energy, right? The correct increasing order of first ionization energy of these ions, right? These are regarding first ionization energy. Of what are the atoms? What are the species given? Na plus is there, fluorine is there, aluminium is there, Cl minus is there, carbon and nitrogen. Those are the species there, right? So they are asking of the increasing order. Increasing order. 1, 2, 3, 4, 5, 6. Right. Yeah, that's the one. Increasing order first ionization energy. What are the things we should know? First, the minimums and the maximums. Minimums and the maximums. I1 minimums and I1 maximums, right? So, Na plus is there, yeah, some ions are also there, right? When it comes to minimums and maximums with the neutral atoms, right? So, this comes as a maximum, no? Fluorine coming up as a maximum, no? It's a I1 max. Right, we don't have minimums here, no? We don't have minimums, right? So it's like this, no? For neutral atoms. Right, I1 max coming up with normally with the noble gases, but fluorine is also included there, right? The helium is the maximum, the smallest noble gas, neon. Then fluorine is there as a VIP, and the argon. Resta with lesser ionization, right? So from here you can come up with the fluorine. Minimums are not there, right? I1 means coming up with the group 1s, no? Right? Potassium, the largest group 1, right? Then sodium like that, no? For considering first 20 elements. Resta less than that, no? Right? When considering these two guys, we can locate the fluorine as a max, right? Okay. But then we have problem, right? So fluorine is there, and sodium plus. What about this? So basically, when you are with positive ions, we are with ions as well, right? This is a good question. Not only with the neutral atoms, right? We are with some ions as well, right? So we have to consider that as well, right? Only with the neutral atoms, these things apply, right? When it comes to ions, so basically with positive ions, right, you are lack of electrons, no? Then it is very hard to release the electrons there. So if you are regarding the Na plus, it is kind of you are trying to do the second ionization. You are trying to release the second electron here, right? So basically we know always the second ionizations are greater than the first ionizations, right? Like that. So releasing second electron is always harder, right? So one can say, oh, this thing as, one can see the electronic configuration of this thing as equal to the neons. The electronic configuration is equal to neons, right? So even neon is with a greater value than the fluorine, but here it is not the neon, and some plus is also there. So this value, the releasing electron from this Na plus is much harder than releasing electron from neon even, right? Neon ටත් වඩා වැඩි අමාරුයි හොඳේ. Neon ටත් electrons 10යි තියෙන්නේ. Sodium plus ටත් 10යි. But here those 10 electrons are attracted by 11 protons, right? Releasing electron here is very harder. So first ionization is for Na plus is greater than the neon even, right? So fluorine ට වඩා neon වැඩි, neon ටත් වඩා sodium plus වැඩි. එහෙනම් sodium plus is the one with the greatest I1 here out of these species, right? So sodium plus coming here, coming with I1 maximum values, right? So then the fluorine, right? Sodium plus is greater than the neon as well, right? 10 neutron system, right? Maximum things are done. You don't have any minimums there, no? Yeah, you don't have any minimums to apply here, right? So what else we can think of, right? So we can go for, and now we have done with these two guys. Yeah, done with these two guys. Few other guys are there. Let's concern about first of all these three guys: aluminium, carbon, and nitrogen. So we can come up with a zigzag along period, right? Zigzag along period. So let's consider second row elements. We can consider second row elements, right? Second row elements, right? The zigzag looks like this, no? Right? You have the carbon, aluminum, nitrogen. So where's the carbon? 1, 2, 3, 4, fourth group. This is where the carbon is appearing, and this is where the nitrogen is appearing, right? Nitrogen is the greater value than the carbon, right? According to that, right? So nitrogen's value is greater than the carbon's, according to zigzag. So how to come up with the aluminium's value? How to come up with the aluminium's value? For that, we can use the diagonal relationship, right? To bring the aluminium towards the second row, we can use the diagonal relationship, right? The fourth one. Right? To bring aluminium to the second row. This is the second row. According to the diagonal relationship, how the aluminium appears. Aluminium is there. So if you are thinking of boron and aluminium, no? Boron, aluminium, things are there like that. Then you have carbon, silicon, right? Phosphorus, nitrogen, things are there. So aluminium can be related to beryllium, no? But that is not that much good, right? Anyway, can't we think of some other thing, no? So this is nitrogen, nitrogen, phosphorus. So let's come up like this. It's better, we can't use diagonal here because diagonal is applied only for the p block guys, no? So what other ways we can use? So basically you can comment with the silicon, no? Right? So silicon is less than carbons. Right? Aluminium is less than silicons. Are you with me? It's like this, no? Silicon would appear here. Right? Aluminium would appear here. As aluminium is group 30. Aluminium would appear here. Silicon would appear here, group 40. Silicon is less than carbons because size is greater than the carbons. And silicon here, aluminium here. So aluminium is less than silicons. That surely says aluminium is less than carbons. Got the idea? Right? No, not that much diagonal there. Right? Still we are using the zigzag. Right? Because zigzag we can say, right? Zigzag and along a period. Down a group, no? Down a group. We can say, right? Aluminium, when considering the carbon and the stuff, right? Silicon is less than carbons. Down a group. And aluminium is less than silicons. Zigzag. Third row zigzag. Right? So we can say aluminium is less than carbons. Right now? So with these things, right? Aluminium, carbon, nitrogen, things appear like this. With the use of silicon, we have derived those things. right? So that is those things are the ones we have to look for, right? And easiest is this one, right? Easiest is this one. That one is the easiest because that is with greater number of electrons. This is the easiest to release electrons. This is an electron because it is with excess electrons, right? So chlorine comes here, the easiest, Cl minus, right? As a negative ion, it is with more than electrons than the nucleus, right? So this is the easiest one, and these guys more. Aluminum carbon nitrate. See, such answer is appearing there. Yes, the answer is answer number 4. Answer is answer number 4. We can't go for the diagonal line because diagonal is related to only the p block guys, right? So if we are think of the atom related to aluminium in the diagonal, it is the beryllium. So we can't use that, right? Okay. So using the first 3 theories of ionization energies, we can solve the question. Right? Ne? Let's come up with the third one. තුන්වෙනි case එක. හරි අවශ්‍ය දේවල් තියෙනවා ළමයි ලියා ගන්න. The IUPAC name of the given organic compound. Right? Okay. Organic IUPAC. Right? Right. This is what they are asking, right? So what is the compound? First let's draw the compound here. So CH3, CH2 is there, and some O is there. Then CO, C triple bond, C. Then what is CH, NH2, C, CH3, right? Okay, this is the molecule. Yes, that is the molecule, right? This is referred to as an ester, right? It's kind of ester, you see. So if you are to examine this molecule, this is the most polar carbon, this is the most polar carbon, this is the most polar carbon. So there the functional group appears. So this functionality is RCCOR, ester functionality. The ester, no, the ester, right? Kind of ester. Ester functionality is there. This kind of thing, R, this kind of thing, ester functionality. Right, let's try to solve this one. So when coming up with the IUPAC nomenclature, right, first thing is to do is actually selecting the main carbon chain properly. Selecting the main carbon chain properly. That is the first thing. 3 things to follow, right? Then we have to number all the carbons in your main carbon chain, right? Third thing is actually naming the substance with the use of general form, right? Those 3 things steps should be followed. First thing is what? Identifying the main carbon chain. Identifying the main carbon chain. How to identify the main carbon chain here? Identify the main carbon chain, right? That's the first thing, right? Identify main carbon chain. Identifying main carbon chain. What are the considerations there? Right? First consideration is, right, most polar carbon. We normally say the functional carbon. Right? And carbon-carbon 5 bonds. of 5 bonded carbons. Should be included. Should be included. Right? That is the first criteria. Under that, under number 1, under this, right, you are looking for chain with more number of subsequent groups. If still you can't find the main chain properly, then under the second rule, the longest chain. Right? So let's identify the main carbon chain. Right? So main carbon chain should come up with carbon-carbon 5 bonds as well as the most polar carbon. So these 3 carbons definitely should be there in your main carbon chain. And always when selecting main carbon chain, the reasons for the most polar carbon to become the most polar carbon should be included, right? So basically this one becomes the most polar carbon because of the polarity of these 3 bonds, right? So those things should be included, right? Reasons to consider this as the most polar carbon is due to these 2 bonds, right? These 3 bonds, those 2 should be included, right? So our main carbon chain is going to be then this one, main carbon chain, right? Okay, we had to find the main carbon chain. Second thing to do, what is the second thing? After identifying the main carbon chain, you're supposed to number all the atoms, all the carbon atoms in main carbon chain. Right? Numbering all the carbon atoms in the main carbon chain. That is the second thing to do. So numbering should be started from which side? Only 2 sides are there. No? We have to number this thing as 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6. Right? From which side we are supposed to start numbering? Basically, we have to start numbering from the side which gives the least number to the main carbon in your main carbon chain. That means you have to give the least number to the functional carbon, this one in your main carbon chain, most polar carbon, right? So start numbering from the side which gives the least number to most polar carbon of our one can be functional carbon. The carbon representing the functional group, right? So so that the numbering should be start from this side because this is the carbon containing the functional group, right? Most polar carbon. So numbering, number 1, 2, 3, 4, 5, 6. All the carbons should get a number, right? Okay. If from the both sides, if you are to get the same number for the most polar carbon, then we have to start numbering from the side which gives the least number to the carbon-carbon unsaturation, right? If from the both sides still you get the same number for the carbon-carbon unsaturation as well, then you have to start numbering from the side, which they give you the least number for the substance group first you meet, right? Okay, that is the idea. Anyway, for this one, this rule will be enough to start to do the numbering, right? Okay. Finally, third thing, after numbering, the third rule, the third step is actually using general formula, using general form of IUPAC nomenclature. General form of IUPAC nomenclature. Right? That is how you're supposed to do, right? So what is the general form? General form means, right, first you should write the substance groups with the number of the carbon connected to it, right? Substance groups. There you have to follow the alphabetical order. Then you have to come up with the term indicating number of carbons in the main chain. In this case, it is 6, right? So if you are with only one carbon, it is, right, meth 2 carbons, eth 3 carbons, prop 4 carbons, bute, like that, 5 carbons, paint, and 6 carbons, it's hex, right? So in this case, it's a hex something, right? Then you have to come up with saturated unsaturated nature, right? If you are all with saturated carbons, only with single bonds among carbon atoms, right? You put the ene term. If you have double bonds with your carbons, carbon double bonds are there, then you have to come up with that number and the ene term. If you have with triple bonds with your carbons, carbon triple bonds, you have to write the related number with ine. I write the e's inside brackets, because if the name of the functional group starts with a vowel, you are not supposed to write the e, right? Then finally, the name of the main functional group. With alcohols, ketones and amines only, you are supposed to come up with the number as well. With other guys, no number is needed with the main functional group, right? Let's name this one, right? So when we are naming the stuff normally, right, these things, substance groups. So what are substance groups here? These are substance groups. These are 2 substance groups in this case, right? This is amine, right? Sorry, this is amino. So that is connected to 4th carbon. This is 4 amino. And this is oxo connected to 5th carbon. 5 oxo. 4 amino, 5 oxo. Right? This is not a functional group now. This is not a functional group, right? For a considering group to concern as a functional group, right, it should be connected to a numbered carbon. It should be connected to a carbon in the main carbon chain. That means that carbon should carry a number, right? But this one is not connected to a numbered carbon, right? So this is not a substance group, right? It is less prioritized even than a substance group. This is less prioritized even than a substance group, right? In such a situation, that will be written, right, prior to the subsume groups as well. Right? Normally, in this nomenclature, right, most prioritized ones are written in right hand side. Coming towards left hand side, priority decreases. Right? So, වඩා වැදගත් කට්ටිය ලියන්නේ main functional group එකනේ. Yeah, priority එක වැඩිම පැත්ත. Indian priority එක අඩු වෙනවා. ඒතකොට වාගේ priority එක අඩුම එක්කෙනා තමයි මෙයා. This guy is with the least priority even than a subsume group. ඒතකොට එයාව සාමාන්‍යයෙන් subsume group එක මේ පැත්ත තමයි ලියන්නේ. හරි? ඒතකොට එයාව සාමාන්‍ය external nomenclature special. හරි? ඒතකොට මේ වගේ වෙලාවට ළමයි මේ එයාව වෙන් කරලා ලියන්නේ, වෙනම ලියන්නේ. එයාව වෙනම ලියන්නේ. හරි මේ methyl group එක අපි වෙනම ලියන්නේ. එයා subsume group නෙමෙයි. Yeah, ethyl group is venom because it is not connected to any numbered carbon, right? Substance group is venom tamai. Itu rutika me ujin naman check karangan. That is how an ester is named, right? So let's write. So ethyl. So passe me ujin ready karangan. This is special for esters, right? Me venom liyan because me substance group here list prioritize because not connected to a numbered carbon even. Ethyl, then substance groups, you have 4 amino, 5 oxo. Have to come up with the alphabetical order. So after the ethyl, you have a space, then amino, oxo. A comes first, so 4 amino. Then you have 5 oxo. No space among here, right? Then starting from the substance group to the main functional group, no space is there. In between the letters and the numbers, you have to come up with a dash. Between letters and numbers, you have to come up with a dash. No spaces, and all the letters should be written in simple letters, right? No capitals, right? Okay, 5 oxo. Then after the substance groups, you are supposed to come up with the number of carbons in the main chain. You have 6 carbons here, hex. Then the term indicating the unsaturated nature. So you have a ion at the second carbon, least number is always written. At the second carbon, ion is there. You are not expected to come up with the E. You are not expected to come up with the E of the ion because the name of the main functional group starts with a vowel, right? So what is the main functional group? It is a kind of ester. So esters are written as OH, 2 ion OH. 2 eno8, right? So this is the name, right? If you wish, right, you can bring this number 2 here as well. If you wish, any number appearing after the number of carbons in the main carbon chain can be taken in front of that term. Right? Again, number of carbons in the main carbon chain to pass a PA number of lamai, what on me numbers in a number quad, minimetanta gain the pulu, number of carbons, term the culling gain the pulu. So this can be written as ethyl 4 amino 5 oxo hex 2 eno8 or ethyl 4 amino 5 oxo 2 hexenoate. 2 hexenoate. Oh, yeah, no pulu. Well, I'm making they are written as like this ne happy ලියපිටෙන්ට ලියලා තියෙන්නේ so ethyl 4 amino 5 oxo hex 2 eno8. So we have an answer there. The answer is answer number 2. Answer is answer number 2. This is your answer number 2. හරි. so සාමාන්‍යයෙන් IUPAC nomenclature වල spaces තියන්නේ නැහැ. හරි. IUPAC nomenclature වල spaces තියන්නේ නැහැ. Spaces in situations තුනයි තියෙන්නේ. What are the 3 occasions where we see spaces between letters in IUPAC nomenclature? The 3 instances are, only 3 are there. When you are naming a carboxylic acid, between the oic and the acid, oic acid, so oic and the acid, you have a space. This is the first instance. Here you find a space in your nomenclature. The second instance coming up with when you are naming, right, oil chlorides, acid chlorides. So between the oil and the chloride, you have space, oil space chloride. And the third instance is this, when you are naming esters, when you're naming esters, right, before writing the substance group, name of substance group, you have to write the R group of the ester, which is connected to the COO minus group, right? And so that R group should be written prior to the substance group, right? So substance groups, right? There you have to maintain a space there, right? Those are the only 3 occasions where we see how space, right, in algebraic nomenclature, right? Ne? Okay, that is the question number 3. Let's come up with the question number 4 then. Right, up here, 4th question. So I'll write the 4th one here. Million. Right. Let's copy the question number 4. See what they are saying. Which of the following statements is false regarding the elements from sodium to chlorine in the 3rd period? Right, we are considering elements of the 3rd period. Right? 3rd period elements. From sodium to chlorine. It is our consideration here, right? Okay. Right, what they are asking, the first statement. Their maximum valencies increase gradually along the period. Their maximum valencies. Maximum valencies increase gradually along the period. It is true, no? So, element and the maximum valency. Maximum number of electrons participating in bonding, that is maximum valency. So for sodium, magnesium, aluminium, silicon, phosphorus, sulfur and the chlorine, the maximum valencies. Sodium is always 1, the last valence electron always participate in bonding, right? Magnesium always 2, magnesium 2 plus is the one it prepares. No? Aluminum always comes with aluminum 3 plus, 3 electrons are participating. Silicon, it SiH4 kind of thing, SiCl4, like this. No? So maximum valence is 4, right? 4 electrons from the silicon participating here. For phosphorus, the maximum valence is 5, PCl5. Sulfate is 6, SF6. Chlorine, the maximum it can go for is 7. Like in ClO4 minus, where the chlorine's oxygen state is plus 7. There you see the maximum valency with chlorine. 7 electrons of chlorine participating there. 1, 2, 3, 4, 5, 1, 2, 3. Sorry, like this, no? 1, 2, 3, 4, 5, 6, 7. Right? So maximum valence is increase going towards right. The statement is true. Right? Statement is true. The statement is true. Right? I'll write it here. Number 1 true. Right? Maximum valence increases. Let's come to number 2. Most of these elements have a higher negative electron affinity when compared to the elements which belongs to the same group in the 2nd period. Right? Same group in the 2nd period. So this is regarding electronity. Right? What we know regarding the electronity, right? Electronegativity, no? Electron affinity. Electron affinity is related to electron gain energy, no? Right? Related to electron gain energy. Right? The relationship is actually greater the electron affinity means greater the electron gain in, right? That's such a kind of relationship is there. Greater electron affinity means greater electron gain, right? Such kind of relationship is there. Greater the electron affinity means greater your electron gain is, right? ये वाली relationship तो है ये, हर तो वाटा एक ने electron gain नहीं वाली करनी electron affinity वाली दमा, हर when it comes to those numerical values, the signs will change, right? Me are negative value आती है नहीं, me are positive value आती है. Sign नहीं करना सुना है, भाई electron negative electron affinity की वाली करनी electron gain की वाली में दमा. Electron affinity means right keenness toward the electrons, likeness toward the electrons, electron affinity. तो कोच्चर कैंप दी की नहीं electron affinity करेगी. Electron gain energy का ताकत रहती है वाली दी अत्ता में दी अत्ता भी बहुत नहीं है. Electron वाली कैंप दी की ना when gaining the electron will release great energy by stabilizing greatly, right? Like that. ये तो मैं ये वाली चीज़ पता नहीं है यार. हाँ रे तो करो मैं क्या तार अल्लाह माय अभी जाने गन्नन कारण होना हाँ greatest first electron gains appears with the group 17s, next highest comes with the group 16s. ये टिका भी जान लो हाँ electron gain का तार दो टिका भी जाने का ना उन्हें greatest first electron gains comes up with the group 17s, next highest comes up with the group 16s. ये का भी जान लो है मैं क्वेश्चन के आंसर को हिंदी मैं क्वेश्चन के आंसर दिए मित्र लावा हाँ मैं क्या आंसर दिए नहीं मैंने मित्र हाँ when it comes to second and third row elements point to the end, right? When considering second and third row elements, point to the end, right? So second row elements are very small compared to third row elements. Compared to third row elements, second row elements are small. Actually, those are too much small. Normally, if you are small, it is easy to attract electrons towards you. If you are small, normally it is easy to attract your electrons towards you, right? So, normally it's like this, right? Normally, when you are small, it is easy to attract the electrons towards you. But if you are too much small, that is what happens with the second and third row elements, right? Second row guys are too much small. පොඩි වෙන තරමට හොඳයි ඊට ඇට්‍රැක්ට් කරන්න පුළුවන් හැබැයි අනවශ්‍යස පොඩි වුණොත් ඒක ප්‍රශ්නයක්. So what will happen when they are too much small, right? Electron repulsions will occur if you are to add an electron to this kind of a smaller volume. To overcome the electron repulsions, right, happening when you are to add an electron, right? To overcome the electron repulsions, some of the release energy will be reabsorbed. That is why the electron gain energy is decreased, right? So too much small, so that, right, electron repulsions would occur when adding an electron to a second row element. Electron repulsions would occur when adding an electron to a second row element. So some of the energy released will be reabsorbed to overcome those repulsions. What I mean, for a example, as an example, right? Electron affinities or electron gains of the chlorine is greater than that of fluorine. This is third row, this is second row, right? And sulfur is greater than that of oxygen. Third row guy is with a greater value than the second row guy. Phosphorus is with a greater value than nitrogen. For all the things other than lithium and sodium, this would occur, right? Carbon and the silicon. Silicon is with a greater value than the carbon, right? Like that. The aluminum is with a greater value than the boron, right? Then magnesium is with a greater value than the beryllium, right? Only with the lithium and sodium this won't happen, but for all the other things, the second row guy is smaller than the third row guy, or the third row guy is with a greater value than the second row guy, because of this electron-neutron repulsions with a too much small situation, right? That is what happens there. So the second statement is true. Most of the elements have higher negative electron affinity when compared to elements which belongs to the same group in second period, right? So statement is true. ළමයි ඒකනේ මේ පොඩ්ඩක් හදාගන්න electron affinity කියනට electron gain කියලා. දැන් අලුත් සිලබස් එකේ electron affinity කියන වචනේ පාවිච්චි වෙන්නේ නැහැ. අලුත් සිලබස් එකේ පාවිච්චි වෙන්නේ electron gain energy කියන concept එක. හරිද? ඒක පොඩ්ඩක් අර හදාගන්න electron gain කියලා පොඩ්ඩක් අර පරණ paper එකේ ප්‍රශ්නයක් ඒක ජොට්ටක්. හරි. just 16 වගේ paper එකකින් ප්‍රශ්න ගත්තේ. එතකොට මේ just 19 න් පස්සේ අපි use කරන term එක electron gain energy කියන එක. so we electron gain විදිහට කතා කරමු. Most of these elements have a higher negative electron gain කියලා ගමු. Have a higher negative electron gain when compared to the elements which belongs to the same group in the second period. Right? Higher electron gain කියලා ගමු. Right නේ? ඉතින් ඔහොම තමයි දෙන්නේ. ඉතින් statement එක true. Right. ඔන්න third statement එක මොකක්ද කියන්නේ කියලා? The ability of these elements to form covalent bonds increases along period. Ability of these elements to form covalent bonds increases along a period. Again, right? The hari neda. Then sodium gathot forms only ionic compounds. Sodium has ionic compounds විතරයි ළමයි. Sodium වෙන covalent compounds නැහැ. Magnesium හරි 95%ක්ම ionic තමයි දන්නේ. කලාතුරකින් ඔය covalent එක හදනවා. කලාතුරකින් ඒ covalent compounds හදන්න පුළුවන්. ඉතින් මේ පැත්තට යන්න මොකද වෙන්නේ? aluminium, silicon, ඊට පස්සේ phosphorus, sulfur, fluorine එක ගත්තා පස්සේ මේකන මම ගාක් හදන්නේ covalent compounds නේ. හරියට covalent compounds හදනවා right. මේගොල්ලෝ නේ ඉතින් බලන්න දැන් Cl2 ගත්ත covalent හරි. එතකොට S8 ගත්ත covalent. elemental forms වලදී covalent ඉන්නේ. හරි. right silicon ගත්ත අර giant covalent disagree තියෙන්නේ. covalent තමයි තියෙන්නේ. right. So more of the covalent things would appear. Right. Covalent bonds increases. Right. Only ionic bonds කියලා bonds වලින් කතා කරන්නේ. හරි. ඉතින් covalent එක වැඩි. හරි. දැන් මෙයාගේ P4 ගත්තත් S8 ගත්තත් ඔක්කොම covalent. හරි. කට්ටියම covalent. මෙයාගේ දෙකම වගේ තියෙනවා නම. ඇලුමිනියම් AlCl3 වගේ අත covalent. ionic plus covalent දෙකම තියෙනවා. So ability to form covalent bonds increases going towards right. That is true. Right. ඕක අපිට ඕන electronic difference එකෙන් කතා කරන්න පුළුවන්. Right? Ability to form covalent bonds increases. Right. So we can take this statement as true. True statement කියලා ගන්න පුළුවන්. Right. Elemental form එකේදී covalent දේවල් හදන්න පොඩ්ඩක් බර වැඩි. දැන් මෙයාගේ elemental form එක ගත්තොත් elemental form එකේ තියෙන්නේ metallic bond. elemental form එකේ තියෙන්නේ metallic bond. විදුන් දෙනාගෙම. හරි. මේගොල්ලෝ elemental forms වල ඉන්නේ covalent bonds. හරි. metals ඉන්නේ metallic bonds. මේගොල්ලෝ elemental forms වල ඉන්නේ covalent bonds. So ability to form covalent bonds increases, right? With the elements, right? හරි. ඒක පැහැදිලි. Number 4. We are looking for the fourth statement, right? When the stable ions are considered, aluminium and the silicon have the respective lowest and the highest ionic sizes, right? So අපි sizes ගත්තොත් right, sodium plus magnesium 2 plus and the aluminium 3 plus ගත්තර වසනේ sodium plus ට වඩා magnesium 2 plus පොඩි. The aluminium 3 plus is smaller than that. How come? These are considered as isoelectronic species. Isoelectronic. With 10 electrons. Right? When it comes to isoelectronic species, right? Greater the positive charge, smaller will be the size. We will attack neither. Isoelectronic species like neither. When positive charge is high, size is small. That is why these guys, right, varies like this, the sizes. Right? It was silicon. Lama silicon won't form ions. Silicon ions හදන්න නෑ අතරම. Silicon won't form ions. Silicon ions හදන්න නෑ. Silicon covalent කට්ටිය විතර හදන්න SiCl4, SiH4, only covalent stuff will be made by silicon. ඊට පස්සේ අනික් කට්ටිය ion හදනවා. P3 minus, S2 minus, Cl minus. Those are the ions formed by them. Normally, if you are thinking of right, monoatomic ions, they will always achieve their nearest Nobel gas configuration. What is the point? So, sodium 2 plus la magnesium 3 plus la 1 plus la monoatomic ions නම් තනි atom එකේ ions නම් ඒගොල්ල හැමතිස්සෙම ඒගොල්ල ළඟම තියෙන Nobel gas configuration තමයි achieve කරන්නේ. එහෙනම් sodium ළඟම තියෙන Nobel gas configuration neon නේ. ඒක achieve කරන්නේ එයාට එක electron release කරන්න ඕනේ. magnesium electrons 2යි aluminium electrons 3යි. හරිද? ඒතර aluminium වෙන වෙන ions හදන්නේ නැහැ. Only the 3 pluses are made. හරි? Magnesium means only form the Mg2 plus. Always the monoatomic ions coming up with the electron configuration of nearest Nobel gas. Right? ඒකෙන් වාර monoatomic ions ලේ charge එක decide කරගන්න පුළුවන්. Right? Okay? එතකොට එහෙනම් phosphorus කිය මොකක්ද? Phosphorus group 15 element, your 15th atom actually, right? Then its nearest Nobel gas coming up with the 18th atom, argon. So phosphorus, the monoatomic ion of phosphorus is going to be then P3 minus. Phosphorus electron 15ක් තියෙනවා. එයාගේ ළඟම තියෙන noble gas එක 18 වෙනි noble gas එක 18 වෙනි element එක. දැන් phosphorus දෙක configuration එක ගන්න තව electrons 3ක් ඕනේ. P3 minus is the right monoatomic ion of phosphorus. For the sulfur, it should be S2 minus. Sulfur electrons නේද 16ක් තියෙනවා. ළඟම තියෙන noble gas එක 18න් ඉන්නේ. එහෙනම් electrons දෙකක් ගන්න ඕනේ. electrons දෙකක් ගන්න කියන්නේ 2 minus. S2 minus is the monoatomic ion of sulfur. What about the chlorine? It is the Cl minus. So all of these monoatomic ions, the P3 minus, S2 minus and Cl minus coming up with 18 electrons. So again, isoelectronic series, right? So when it comes to isoelectronic series, greater the positive nature, smaller your size is. So the things would appear like that. This right then P3 minus, P3 minus, then S2 minus, and the Cl minus. Right? So these three guys are considered as isoelectronic series. But with not 10 neutrons, 18 neutrons. So these guys are with 3 energy levels, 3 electronic shells. So that those should be with greater size than things with 2 electronic shells. These guys are with 2 electronic shells. These guys are with 3 electronic shells. Though definitely these guys should appear larger than these guys. Even the smallest out of these 3, the chlorine, should have a greater size than the largest of these 3, sodium plus. Because these guys are appearing with 2 electronic shells while these guys are appearing with 3 electronic shells. More the electronic shells are, that means your size would be larger, right? So I treat with 18 electrons. Again for this thing also I use the same theory. When positive nature increases, size decreases, right? That is why the size decreases from here to here. So with this you clearly see the smallest positive ion is the Al3 plus and the largest ion is the P3 minus, right? So what they are saying, when the stable ions are considered, aluminum and silicon have the respective lowest and the highest. No, the lowest is okay, this is the lowest, this is the smallest, but this is the largest, not the silicon. P3 minus coming up with the largest. So the statement is false. That is your answer there. That is the answer. So 4 is the answer. Answer is answer number 4. We are looking for the fourth statement. Answer is answer number 4. Right now? So the fifth one, magnesium oxide has the highest melting point among oxides of these elements. Let's see. So that is true lavanya. මේ oxides ගත්තට පස්සේ magnesium oxide තමයි අතරම highest melting point එක තියෙන lavanya. It's a strong ionic lattice, magnesium oxide. Normally its melting point is around 3200 Celsius. Magnesium oxide. Right? So very high melting point. The statement is true. Right? Statement is true. So as a fifth statement, magnesium oxide is with the highest melting point. Normally that value is 3200 Celsius among oxides, no? From sodium to chlorine elements. First statement is true. It is coming up with the very strong ionic lattice. Very strong ionic lattice is there, right? With 2 minus and 2 plus. 2 minus 2 plus තියෙන හොඳ ionic lattice එකක් එක්ක sizes උත් ගන්න set ලා තියෙනවා යාගේ. හරි හොඳටම set වෙනවා. Magnesium 2 plus O2 minus sizes උත් සමානයි වගේ නිකන්. 10 electrons each. charges තුන තියෙනවා. හොඳටම හැදෙන ionic lattice එකක්. Right? So right, this form of ionic lattice formed basically, right, from the magnesium oxide. Very limited spacings among ions there. Very good solid. Right? Good closely packed structure. ඔය structure එක හැදෙලා මේ හොඳට pack වෙලා තියෙන structure එකක්. solid එකක් විදිහට හොඳටම හැදෙන structure එකක්. මොකද එයාගේ sizes තුනක් ළඟයි. 10 electrons each. And charges තුනක් තියෙනවා. +3 and +2. ඒකත් හොඳටම set වෙන මේ lattice එකක් තමයි ionic lattice එකක්. So coming up with the 3200 Celsius as it is reported, right? So it's a very large value, right? Okay. මේ පැත්ත කට්ටිය කියනවා මේගොල්ලෝ කට්ටිය ඔක්කොම හදන්නේ කවුද? Covalent oxides. Covalent oxides. So those will bound with second interactions then. SI ඔයාගත්තොත් මේද phosphorus oxide SO2 වාහන දාන්න oxide එක, chlorine oxide එකේම ඒවත් මෙතන SO2 නම් තියෙන gas state එකේනේ. බලන්න. Those the non-metals form covalent oxides. Right? Non-metals form covalent oxides. So covalent oxides are bound with, the particles are bound with second interactions, London forces. So that melting points are low, right? Melting points are low. But when it comes to magnesium oxide, that is the best. The magnesium oxide is very optimum. Then charge එක පැත්තෙනුත් sizes පැත්තෙනුත් හරි optimum එකක්. සාමාන්‍යයෙන් වට දෙන්න පුළුවන් මේ right sodium oxide හොඳ වෙයි කියලා magnesium oxide වල එහෙම නැහැ. sodium oxide ගේ අවුල මොකද්ද? sodium oxide ගේ cation එකේ charge එක +1 වුණාට හරි දැන් අපිට හිතනවනේ මේ Fajan rule එකට අනුව sodium oxide will form a greater ionic bond කියලා නෑ එහෙම නෙමෙයි case එක. ionic bond එකට charge එකත් වැදගත්. දැන් charge එක +2 වෙනකොට ළමයි මේ හොඳ ionic attraction එකක් තියෙනවා. +2 and +-2. The two particles will attract heavily with a +2 and a -2. और එහෙම ප්‍රශ්න ionic lattice එක පැත්තෙන් ගත්තට පස්සේ magnesium oxide කියන හරියම හොඳ closely packed වෙන structure එකක්. sodium oxide වගේ නෙමෙයි. sodium oxide +2 නෙමෙයි තියෙන +1 නේ තියෙන +1 charge එකකින් -2 attract වෙන sodium oxide. magnesium oxide +2 and -2 attract වෙන. ගානටම සෙට් වෙනවා. කාට හරි පුළුවන් ඇලුමිනියම් ඊට වඩා හොඳයි කියලා නෑ. අර කතාවක් තියෙනවා ඕනම දෙයක මේ ඕනම දෙයක් ඕනට වඩා ඕනේ නැහැ කියලා. හරි. ඒතකොට ඕක තමයි ඇලුමිනියම් ප්‍රශ්නේ වෙන්නේ. ඇලුමිනියම් charge එක ඕනට වඩා වැඩි +3 වෙද්දී. +3 තරම් charge එක වැඩිම වෙද්දී මේ ආයතන Fajan rule එක එනවා වැඩියට. +3 තරම් charge එක හුඟක් වැඩි වෙද්දී covalent character එක rise වෙනවා. Cationic charge is very heavy. Covalent character will rise. ඒතකොට ආයතනය කර ප්‍රශ්නේ එනවා. magnesium කියන optimum එක. cationic charge එක වැඩිත් නෑ අඩුත් නෑ ගානටම හරියම විදිහට තියෙන එක. right? structure එක හොඳට pack වෙනවයි හැම දෙයත් එක්කම හොඳම විදිහට set වෙනවා තමයි magnesium oxide කියන්නේ. මේ value එකත් very high value එක දිනනවා. හරි? ඒක විදියා ගන්න එක වැදගත් case එකක්. හරි? Fifth one. Right? So the answer is answer number 4, right? We had looked for the fourth statement, it was 4, right? Let's come to the fifth case. First one. Right, first case. Which row gives the correct details about nitrogen in difluorooxide? Right, difluorooxide into F2. මේ අදිමු මුලින්ම. Right, N2O2. දැන් මේගොල්ලෝ මේකට මේගොල්ලෝ මේ skeleton එකක් දීලා නැහැ. If they haven't provided any kind of a skeleton, you are supposed to draw a structure with only one single central atom in it. එක central atom එකක් තියාගෙන structure එකක් අඳින්න. තමයි අපි expect කරන්නේ. අපිට මදින්න පුළුවන්ද? හරිද මේ සාමාන්‍යයෙන් අපි expect කරන්නේ ඒ වගේ structure එකට යන්න කියලා. මේක skeleton දීලා නැහැ නේද? right? skeleton දීලා නැහැ වගේ. ඔව් නේ. හරි බලමු එහෙනම් මේ කොහොමද structure යන්න පුළුවන් සාමාන්‍ය ළමයි ස්කෙලිටන් දීලා නැත්නම් මොකක්ද එක සෙන්ට්‍රල් ඇටම් එකක් අරන් අඳින්න කියලා තමයි සාමාන්‍ය කියන්නේ. ඒතකොට ඒ වගේ බැලුවොත් නම් ඔයාලා අඳින්න වෙන්නේ මෙහෙම. right? ඔයාලා ස්ට්‍රක්චර් අඳින්න වෙන්නේ මෙහෙම. right? එක සෙන්ට්‍රල් ඇටම් එකක් දාලා ගොඩ දාන්න ගියොත් ඔයාලා ස්ට්‍රක්චර් එකේ ඉන්නේ කොහොම නේද? සාමාන්‍ය ළමයි ඊළඟ වල මොකක් කරලා පාවිච්චි කරන දේ තමයි මේ ස්කෙලිටන් එක දීලා නැත්නම් එක සෙන්ට්‍රල් ඇටම් එකක් අරන් තමයි ස්ට්‍රක්චර් එක අඳින්නේ. unknown structures දන්න දේවල් වල. හරි? ඒක ඔය වගේ ස්ට්‍රක්චර් තමයි අපි අඳින්න වෙන්නේ. හැබැයි මේක මීටට හොඳට අඳින්න තිබ්බම අර මෙහෙම ඇන්දරා. right? නමුත් අර සාමාන්‍ය ඊළඟ වල කතාව තමයි ස්කෙලිටන් එක දීලා නැත්නම් අපි එක්ස්පෙක්ට් කරන්නේ එක සෙන්ට්‍රල් ඇටම් එකක් එක්ක ස්ට්‍රක්චර් එක අඳින්න කියන එක. හරි? බලමු මේ අපිට කියනවා මේ ස්කෙලිටන් එකත් එක්ක හොඳයි කියලා. පොඩි ප්‍රශ්න පොඩි අවුලක් තියෙනවා. සාමාන්‍ය පොඩි අවුල විදියට ගන්නවා මේ ස්කෙලිටන් එක දීලා නැත්නම් ඊළඟට අපි එක්ස්පෙක්ට් කරන්නේ එක සෙන්ට්‍රල් ඇටම් එකක් එක්ක අඳින්න කියන එක. right? ඒකට මේක තමයි සාමාන්‍ය ඊළඟ ළමයෙක් අඳින විදිහ. සාමාන්‍ය ඊළඟ ළමයෙක් සාමාන්‍ය අඳින්නේ මෙහෙමයි. ඊළඟ සාමාන්‍ය අඳින්නේ මෙහෙම ස්ට්‍රක්චර් එක. හරි? ඒ බලමු ආන්සර් එකට කොහොමද යන්න පුළුවන් කියලා. මම හිත දෙකෙන්ම ගියට ආන්සර් එක වෙනස් වෙන එකක් නැහැ කියලා මම හිතනවා. මම හිතනවා ආන්සර් වෙනස් වෙන්න බෑ කියලා හින්දා ප්‍රශ්නේ අවුලක් තියෙනවා. සාමාන්‍ය ළමයෙක් කියන්නේ මෙහෙම හරි. If they haven't provided you the skeleton, then you are supposed to draw a structure with only one single atom, one single central atom, right? Okay. හරි. ඒක මේක තමයි අපි ප්‍රෙෆර් කරන්නේ ඊළඟ මට්ටමින්. හරි. බලමු. ස්කෙලිටන් දීලා නැති නිසා, right? හරි. අපි මේ ස්ට්‍රක්චර් එකකින් ගිහිල්ලා වැඩේ කරමුකෝ ඕන්න. මේ ස්ට්‍රක්චර් එකකින්. එතකොට මුලින්ම අහන ඔක්සිජන් ස්ටේට්, charge, hybridization මේ කතා ටික මොකක් අහනෝනේ. හරි. එතකොට මේ ස්ට්‍රක්චර් අනුව නම් මේ ස්ට්‍රක්චර් අනුව ළමයි ගත්තොත් මේ ටිකක් වෙනස් වෙන කෙනින් ටිකක් තියෙන්නේ. හරි. ඒතර මේ ස්ට්‍රක්චර් එක නෙමෙයි වෙන්නේ නැති මේ ප්‍රශ්නේ අනුව ඒගොල්ලෝ සෙට් කරනවා ඇති. මොකද which row gives the correct detail about nitrogen in nitrogen difluoride in the following table. So එතකොට එහෙම කරද්දී they are asking for the nitrogen නේ. සාමාන්‍යයෙන් ඒගොල්ලෝ nitrogen ගැන අහන්නේ. ඒතර මේ nitrogen ගේ එකකින් පොසිටිව් එකක් තියෙන නෙගටිව් දිනනවා. හරි. ඒතර එක nitrogen එකක් ගැන අහන්නේ. ඒතර ඒක නිසා මේක නෙමෙයි වෙන්නේ නැති ඒගොල්ලෝ කන්සර්න් කරන්නේ මේ ප්‍රශ්නේ හැටියට ප්‍රොෆෙසර් ඉතලා තියෙන්නේ මේක නෙමෙයි වෙන්න ඕනේ. හරි. ඒතර ඒ අහලා තියෙන්නේ මේක වෙන්නේ නැති. සිමෙට්‍රික් නයිට්‍රේට් වල තියෙන්න ඕනේ කියලා හිතනවා ප්‍රශ්නේ හැටියට නේද? දැන් අපි දැන් මේ ප්‍රශ්නේ මෙහෙම ගත්ත කියලා හැමදාම මෙහෙම ලියන්න යන්න එපා. හරිද? ප්‍රශ්නේ හැටියට පොඩ්ඩක් පොඩි චේන්ජ් එකක් දාගන්න පුළුවන් වෙන්න ඕනේ. සාමාන්‍යයෙන් A level වලදී මම ආයෙසරක් කියනවා අලුත් ස්ට්‍රක්චර් එකක් දුන්නොත් without a skeleton you are expected to draw the structure with only one single central atom. හරිද? හැබැයි මේ ප්‍රශ්නේදී අපිට ඒක ගන්න බැරි වෙනවා. මොකද මේකේ අහලා තියෙන්නේ which row gives the correct detail about nitrogen. nitrogen කියලා අහලා තියෙන්නේ. නිකන් nitrogen අහන්නේ. ඒක නිකන් nitrogen එවුවට පස්සේ ඔයාලට මෙතන nitrogen දෙන්න chemical elements වෙනස් නම් අපිට ඒකට ආන්සර් එකක් දෙන්න බැරි වෙනවා. the question එකේ හැටියට අපිට මේ ස්ට්‍රක්චර් එක පැත්තට යන්න වෙනවා. මේකෙන් හැවුවා කියලා තමයි හිතන්න වෙන්නේ. හරිනේ? ඉතින් ප්‍රශ්නේදී මේ වගේ දෙයක් හදාගන්න පුළුවන් වෙන්නත් ඕනේ ඔයාලට. ප්‍රශ්නේ හැටියට. හරිද? එයි මම මේ ස්ට්‍රක්චර් කන්සිඩර් කරේ මොකද්ද? because they are asking just for the nitrogen. Yes, as they are asking just for the nitrogen, definitely they are thinking of two nitrogens appearing with the same chemical environment. හරිද? ඒගොල්ලෝ නිකන් nitrogen කියලා අහනකින් ඒගොල්ලෝ අදහස් කරන අපිට හිතන්න වෙනවා එහෙනම් nitrogens ලා දෙන්නගෙම නැත්නම් nitrogen තියෙන හැමෝගෙම chemical environment සමානයි කියලා. නැත්තම් බෑ නැත්නම් අපි ආන්සර් එකක් දෙන්න බෑ ළමයි මේ chemical environment වෙනස් වෙද්දී ප්ලස් ද නෙගටිව් මොනවද කියන්නේ? එහෙනම් ඒක නිසා තමයි මේ ස්ට්‍රක්චර් එක කන්සර්න් කරලා උත්තරයට යන්නේ. රයිට් නේ? හරි. නැත්නම් සාමාන්‍යයෙන් ප්‍රශ්නයක් වුණා 2 nitrogens කියලා වෙන වෙනම අහලා තිබ්බා nitrogen දෙන්න කියලා. ඒතර අපි කන්සිඩර් කරන්නේ මේ ස්ට්‍රක්චර් එක. රයිට්? හරි. රයිට් අපි බලමු එහෙනම් මේ ස්ට්‍රක්චර් එකෙන් උත්තරයට යන්න. So see, let's copy this one. First thing is oxygen state. Oxygen state. How to copy the oxygen state? So what is oxygen state? Oxygen state is what? Oxygen state is actually the charge on the considering atom if all the bonds are considered to be ionic. The charge on the considering atom if all the bonds are considered to be ionic. Again I am telling you oxygen state is what? Oxygen state is the charge on considering atom if all the bonds are considered to be ionic. Right? අපි ගිය සතියේ කතා කරා oxygen state එක ගන්නවදීනේ. එහෙනම් බලමු. එහෙනම් මේ bond එක ionic වෙනවා නම් if this bond is kind of ionic, the electronegative atom gets the negative charge, electropositive atom gets the positive charge if this bond is ionic. if this bond, one of these bond is ionic, right? Actually that won't happen, no? These are pure covalent, right? 100% covalent, we can think like that, right? Because these bonds are among two atoms with same kind of electronegativity. Electronegativity සමාන atoms දෙන්න එක අතර තියෙන bonds දෙක. එතකොට ඒක ionic nature එකක් නැහැ. No ionic component there. So if you are considering this one, if this bond is considered to be ionic, the electronegative atom should get a negative charge, electropositive atom should get a positive charge out of the two atoms of the bond, right? හරි එහෙනම් වාගේ if all the bonds are going to be ionic, this guy's oxygen state is going to be what? Oxygen state is going to be +1. For this guy as well, around this 90, you just have only +1. So that +1 the oxygen state again. Charge is 0, right? Charge is 0. Charge at the beginning, the oxygen state minus charge then charge is 0. So oxygen state is +1. Charge on these atoms are 0. So what's the hybridization? We have 1, 2, 3 wave speeds. That means hybridization is sp2. Three wave speeds means sp2 hybridization, right? Then electron pair geometry. 3 wave speeds means what is electron pair geometry? 3 means trigonal plane. Electron pair geometry, right? Trigonal plane electron pair geometry, right? So what are the answers available like that? +1, charge is 0, sp2, trigonal plane. So only one such an answer is there. That is answer number 3. No need of orbital overlap even. Answer is answer number 3. Oxygen is +1, charge 0, hybridization is sp2, trigonal plane electron pair geometry, right? These 3 wave speeds, electron pair geometry is trigonal plane, right? So you can think of the orbital overlap as well. For the central atoms, for the orbital overlap, for the central atoms, for the orbital overlap, what are the things used? The hybrid orbitals, right? As this is a central atom, sp2 hybrid orbitals will be used for the orbital overlaps, and from the common atoms, right? Ultimate electron filled subshell will be used. Ultimate electron filled subshell will be used from the common atoms for the sigma bonds. That means it is the 2p from fluorine and sp2 from nitrogen. That is the orbital overlap. So answer is answer number 3. Clear, no? Answer number 3. Alright. Right. Let's complete 6th one. Number 6. Balance number 6 se oda dindi. Question number 6. Right. Given below is a step in the mechanism of a certain reaction in organic chemistry. Given below is a step in the mechanism of a certain reaction in organic chemistry. Right? What is this one? So you have this kind of a thing. Right? Some carbon is seen, right? And some electrophile is nucleophile is attacking to that thing. Carbon is there. Some nucleophile is attacking. Nuclear loving group, nucleophile will attack to form this one. Right? කොලන් මොකක්ද අහන්නේ කියලා? which of the above statements are true? They are looking for the true statement. Or true statement එක අහන්න. බලන්න. One of steps in the mechanism of reaction between 2-methylpropane and dilute H2SO4 is shown below. Right? බලමු. පොඩ්ඩක් ඒක ලියලා බලමු. මොකක්ද මේ කියන්නේ? කියලා. හරි. ඔයාගේ A statement එක ගත්තොත් A කියන statement එක ගත්තොත් one of the steps in the mechanism of reaction between 2-methylpropane and dilute H2SO4. 2-methylpropane කියන්නේ මොකද්ද? propane, methylpropane, 2-methyl. 1 2 meth eth prop, propane meth eth prop. 2-methyl 1 2 at the second carbon methyl group is there. 2-methylpropene. 2-methylpropene is like this. 2-methylpropene. 2-methylpropene කියන්නේ මේ වගේ මොලිකියුල් එකක්. And the H2SO4. කොහොම mechanism එක යන්නේ? H2SO4. You have the H2SO4, right? This is H2SO4. So you have a positive here, negative here. So this comes here, this goes here. So we'll produce this thing. Right? Harana මේ hydrogen set වෙන්නේ according to Marconic flow, the hydrogen will be connected to the hydrogen will be connected to form the most stable carbon. That means hydrogen will be connected to the carbon with more number of hydrogens, right? Hydrogen will be connected to the carbon with more number of hydrogens to form the most stable carbon. So that hydrogen should go towards here than here. This carbon with 2 hydrogens, this carbon is with 1 hydrogen. Hydrogen goes to the carbon with more number of hydrogens. So CH3 and plus comes here. Right? O minus SO3H. දැන් පළවෙනි ස්ටෙප් එක. ඊට මේකේ සෙකන්ඩ් ස්ටෙප් එක මොකක්ද? මේ මෙකනිසමේ සෙකන්ඩ් ස්ටෙප් එක තමයි ළමයි. මට මතක නම් මේ මෙකනිසමේ සෙකන්ඩ් ස්ටෙප් එක වෙන්නේ to the carbon not the OH minus attack. To the carbon not the OH minus attack. In water addition to the carbon this is the one which will attack. මතක නම් ඕලට මේ මෙකනිසම් එක හරිද? alkene එක H2O addition එක carbon එක attack කරන OH නෙමෙයි. This one. This will produce nucleophile will attack. So the second step කියන්නේ මෙහෙම. carbon attack කරන්නේ OH නෙමෙයි. එතකොට එහෙනම් මේ statement එක වැරදි. මේ attack කරන OSO3H. O minus SO3H. That is the second step of this reaction. Water addition of water addition of alkenes. Third step එක තමයි මේ third step එකේදී මෙයාට attack කරන එකක් තමයි තියෙන්නේ. මම එකක් උන්න ලියන්නම්. Third step එකේදී මෙහෙම වෙනවා. Third step එකේ තමයි ඔයාට අපි ලියන්නේ. When adding water you produce the alcohol කියලා ඔහොම තමයි resource book එකේ තියෙන්නේ. Connecting the OH here. When connecting this can be considered H and OH, right? When connecting OH, some H is released. That H will connect with this thing to come up with the H2SO4. Then I mentioned HSO4 in another. May should set no H2SO4 catalyst. So this is not a step in the addition of water molecule to alkene. So this is a false, right? Statement is false. False statement. Alright. Again, false statement. Yeah. Sorry, I'm going to tell statements. You ready, right? So we are with the part A. Right, we'll come up with the statement B as well. Question number 6 again. Alright, this statement B here. This is all about question 6, right? A is false. B. One of the steps in the mechanism of reaction between 2-chloro-2-methylpropene and NaOH is shown there. First of all, let's draw the structure. 2-chloro-2-methylpropane. Propane. It's a propane. Meth, eth, prop. 2-chloro-2-methyl. At the second carbon, methyl group is there as well as a chlorine group is there. 1, 2. 2-chloro-2-methylpropane. Right? Okay. This is the structure. This thing reacting with NaOH. Reacting with NaOH, that means OH minus. Right? NaOH. So this is a tertiary carbon, tertiary halide. This is tertiary halide. This is tertiary halide. This is kind of a nuclear substitution of a tertiary halide. When it comes to nuclear substitution of tertiary halides, what happens? First you form the carbocation. First, this chlorine leaves like this and forms the carbocation. When it comes to nucleophilic substitutions of tertiary alkyl halides, first you form the carbocation by leaving the halide. Carbocation mechanism. This is actually what? This is actually nuclear substitutions. The two-step mechanism. This in one. Two-step mechanism. As tertiary halides are involved. Right? First you form the carbocation. Then to the carbocation, the nucleophile will attack. So your carbocation is there at the second step. Your nucleophile is OH minus. That will attack like this. Come up with the ultimate product. Right? So what they are saying is one of the steps in the mechanism of reaction between 2-chloro-2-methylpropane and NaOH aqueous is shown above. Yes, that is true. So this section is appearing. This section is appearing with this mechanism. See this one, right? Okay, same section. So this is true. Right? See the C statement. The stability of CH3C, that tertiary carbocation shown here, is greater than the stability of that thing. Carbocation stability. Right? You have a tertiary carbocation here. This is a tertiary carbocation, right? So what you are forming here is a tertiary carbocation. This is tertiary carbocation. But you are supposed to compare this thing, the stability of this thing, with this one. Right? Even though this looks like a primary carbocation, this is a carbocation which can be stabilized by the resonance. Right? This can be stabilized by the resonance. See? How come? Right? These electrons can be transferred to here and can be stabilized by the resonance like this. Stabilized by resonance. This covalent is a covalent which can be stabilized by resonance. So if you can stabilize the covalent by resonance, such a covalent is with a greater stability than the covalents which stabilized by the R group effect, right? So is a covalent stabilized by resonance. Is stabilized by R group effect. So all the covalents which is stabilized by the resonance is with a greater stability than the covalent stabilized by the R group effect, right? So this one is with a greater stability than this one. So the statement is false. They are saying this is stable. No, this is the one which is more stable than this, right? So the statement is false. Right, now wait again. Right. The fourth statement. This statement says CH3C plus is an intermediate product in the reaction between 2-methyl propane and dill H2SO4. 2-methyl propane and dill H2SO4. Right. Earlier it is also 2-methyl propane and dill H2SO4. So CH3C plus one of the steps in reaction between 2-methyl propane, the same thing, propane and dill H2SO4. So we have a problem. Plus is an intermediate product in the reaction between. Do we see such kind of a intermediate? Right, no? Yes, we see such kind of intermediate, right? Okay. So same thing, right? At the A as well as D, they are concerning over the same mechanism, right? At the A statement, it is all about 2-methyl propane and the dilute H2SO4 with this thing as well, right? So yes, it's a kind of a right intermediate, right? You see, this is intermediate, right? This mechanism is coming up with this is intermediate. So statement D is true. Statement D is true. Right, you can look for review or look the mechanism, look the mechanism. Shown in A, you see the intermediate, right? So your A, so what are the true statements? B and D are true. B and D are true. So that the answer is answer number 5. Answer number 5. B and D are true. Right? Right. That is the review for the question number 6. Let's quickly go towards question number 7. Alright. Hard. अब हम क्वेश्चन नंबर 7 निकलना है. Right. Question number 7. See, which of the following statement is true regarding lithium? It's all about lithium. See, though lithium reacts with steam, it does not react with hot water. Right? What you know about the reactivity of S elements? With H2O, how things looks like this, no? To have some picture: lithium, sodium, potassium, rubidium, cesium, calcium, strontium, barium, magnesium and beryllium. All of these guys, this section reacts with, right? Reacts with, I'll write like this, reacts with water, water, right? Liquid, cold water, let's see, cold water, sorry, cold water reacts, hot water reacts, steam reacts. If you are reacting with cold water, definitely with the other two forms, more energized forms, the reactions will occur. If you are reacting with even the less energized form, the cold water, definitely with hot water and steam, the reaction will occur. Right? Cold water means the H2O at 25 Celsius or less than that. Hot water means the H2O between the room temperature and the 100 Celsius. Hot water. Steam means H2O beyond 100 Celsius. Right? Okay. So when it comes to magnesium, not reacting with cold water, negligible reaction rate, right? So with hot water, yes, reaction starts with hot water, and with the steam as well, reaction will happen. With cold water, no reaction. With beryllium, with water, no reaction. Cold or hot, with water, no reaction. You need steam to react the beryllium, right? Those are the reaction patterns, no? So we are referring to lithium. Yes, lithium will react with all the three kinds of water, three kinds of H2O, right? So lithium reacts with steam. It does not react with hot water, means it's false. It reacts with all the three forms of water, lithium. The statement is false. Statement is false. This is all three forms, right? Statement is false. Next one. Lithium reacts with excess air at high temperature and produce lithium nitrate, those three stuff, right? Okay, let's discuss about reaction of S block guys in air, right? S block group 1 guys in air, right? Reaction of, so what are the major components in air? N2 gas and O2 gas, right? Okay. Okay, if you are considering air, major components are N2 gas, right? 78%, and O2 gas. So reacting with air means basically we are referring to these two guys, right? Right? So I'll consider the group ones. So both are both, okay. S block elements. First, let's discuss with O2 gas. S block elements with O2 gas. Right. S block elements with O2 gas. How they react? Right. Group 1s and group 2s. Group 1s. Lithium only produces the oxide. Sodium produces oxide. The excess addition will produce peroxide as well. Potassium, rubidium, cesium, right? Will produce oxide, peroxide, superoxide, all the stuff. Mixture. Right? Even superoxides. KO2. These are superoxides, right? So out of these things, what are the major products? Sodium will produce both the stuff, but peroxide is the major product. Out of these guys, the superoxides are the major product. Right? These are the major products. Product mixtures will be formed, and these are the major products, right? So here, these are the oxides. These are the peroxides. These are the superoxides. Oxides, peroxides, and superoxides. Right? So lithium produces only the oxide. We are considering on the lithium, right? Okay. Right. With O2 gas. Right? I'll just consider the group 1s lamai, right? For lithium is enough, no? I'll just consider the group 1s as we are with only limited time, right? So let's consider only the group 1s, right? Okay. Right. What about the group 1s with N2 gas? Group 1s with N2 gas. Right? So only lithium will react as a group 1 element with N2 gas, not the other guys. Others won't. So lithium reacts with N2 gas to produce lithium nitride. Others won't. Definitely you need to heat the stuff, right? Without heating, that won't happen. No reaction. Right? We are considering about the lithium, so that with O2 gas, it will produce the oxide, and with N2 gas, nitride. මේ excess oxygen එක react කරන අනිවාර්යයෙන්ම රත් කරන්න ඕනේ, හරි? Without heating, you won't get these peroxide and superoxide, right? To get the obtain the peroxide and superoxide, definitely it is necessary to heat, right? Okay. Anyway, let's again consider about the lithium. When considering lithium with oxygen, you form the lithium oxide, and with nitrogen, it forms the lithium nitride. right? So those are the two products. Lithium reacts with excess air at high temperature and produces lithium nitride. Then the nitride is there, that is done. This thing is okay. The nitride is there. And oxide, that is okay. Lithium, what was that? That is lithium superoxide? No. Lithium won't produce superoxides, right? Only the bottom three of the group 1 produces superoxides. Lithium won't produce superoxide, right? So the statement is false. Lithium won't produce superoxide. Oxide will be formed, nitrates will be formed, but not the superoxides. Lithium form only the oxides, right? No superoxides with the lithium. Superoxides are formed only by the potassium, rubidium and cesium. Right? No? Okay. So that's it. So the statement is false then, because lithium won't produce superoxides. Right. Third one. Lithium carbonate is thermally stable. What about that? Thermal decompositions. Thermal decomposition patterns. So lithium comes under moderately active. Lithium comes under moderately active. When it comes to thermal decomposition patterns, what are the active guys? Sodium, potassium, rubidium and cesium. What are the inert guys? Mercury, silver, platinum, gold. All others moderately active. All others. All other metals. Moderately active. So lithium comes under moderately active metals. So for moderately active metals, how the carbonates are supposed to decompose? For moderately active metals, carbonates will decompose, giving you the oxide and CO2, right? So for moderate will decompose, giving you the oxide, metal oxide and CO2. So for lithium, its carbonate will decompose, giving you the lithium oxide plus CO2. Right? So it is not stable, decomposes. It's not stable, decomposes. Right? Decomposes. Not thermally stable. Thermally stable means no decomposition should occur, right? But lithium carbonate decompose. So statement is false. Carbonates of moderately active metals will decompose, giving you the oxide and CO2. Right? Alright. Fourth one. Then fourth thing. Lithium bicarbonate cannot be obtained in solid state. මොකද්ද point එකේ? ළමයි, when concerning bicarbonates, only the active metal bicarbonates can be obtained as solids. That is the point there. Only active metal bicarbonates. Can be obtained as solids. ඒකෙල්ල මේගොල්ලෝ විතරයි. Sodium carbonate, potassium carbonate, rubidium carbonate, cesium carbonate. මේගොල්ලෝ solids at room temperature. All other carbonates solid නෙමෙයි. solid නෙමෙයි. මොකක් හරි විදිහකට ඇති solid නෙමෙයි. normally appears as aqueous stuff. පොඩාර වතුරත් absorb කරන නිසා එහෙම dissolve වෙලා වගේ තියෙන්නේ. but can't obtain as solids. solids නෙමෙයි. හරි. so the statement is true. Lithium cannot be obtained in solid state. Yes. Lithium is not an active metal, right? Not considered as an active metal according to the thermodynamic trends, right? So it won't appear as a solid when it comes to bicarbonate. So bicarbonate, right? Not the carbon. Sorry, Lama. It's bicarbonate, right? Bicarbonate, right? Carbonates can be obtained as solid, right? Bicarbonates, right? Right. Okay. Let's come up with the next stuff. So answer is answer number 4. Right? This is just about the fifth statement as it. Thermal equilibrium for lithium nitrate produces lithium nitride and O2. Right? So it's about moderately active metal nitrate decompositions resultant, right? Metal nitrate will decompose to give the metal oxide when it comes moderately active metals plus O2 plus NO2. So for lithium nitrate, so lithium comes up with this now. Lithium nitrate, no? That thing will decompose to give you lithium oxide plus O2 plus NO2. Not the lithium nitride, this is lithium oxide. The lithium oxide we are supposed to obtain, not the nitride. Nitrides will be obtained by the active metal nitrates. If you are to decompose a sodium nitrate, it will give you sodium nitrite. Potassium nitrate will give you potassium nitrite. So nitrate decompositions will produce the nitrites if the metal there is kind of an active metal. But with the moderately active metal nitrates, it is the oxide which forms, right? So the statement is false. The true statement is 4. So answer is answer number 4. So answer is answer number 4 for the question number 7. Right now? Right. Let's come up with the question number 8. right. Attorney wala. This is regarding the IUPAC nomenclature of some inorganic coordination complex. Right. This is a coordination compound, right? This is a coordination compound, not an ion, just a coordination compound containing a complex ion and a cation and a complex anion. The coordination compound containing a complex cation and a complex anion, right? So how we are supposed to write the name here? First write the name of the complex cation and then write the name of the complex anion with a space between them, right? For a coordination compound, first write the name of the complex cation and space and write the name of the complex anion, right? That is what we are doing. Name of the complex cation here and space. Always between the cation and anion you have space and the name of anion. Here it's a simple anion, right? Here they are looking for a simple anion. Alright. Right. So what is this one? CO NH 5 times in OH. So you have CO NH 5 times OH. Your cation, this is your anion. Then no two. Then Miagram. Comolian now. When writing the name of a cation, write the name of cation. How to write the name of cation? First, you have to write the ligands in alphabetical order. Ligands in alphabetical order, right? Name of cation. Right? Common name of cation lian. Name of a complex cation. Common lian. First, write ligands in alphabetical order. Without a space, then write in the name of the central metal ion. Right? Then coming up with the oxygen state. Inside brackets. Oxygen state inside brackets. Right? And ultimately the ion term. This is how we're supposed to name a complex cation, right? But in this case, we are not writing the ion term because it is a compound. It is a compound, so that we are not writing the ion in this question, right? Naming a compound. Iron එක ලියන්නේවා compound එක ලියන්න නිසා. හරි. කෙලින්ම මෙයා විතරක් නම් හිටියේ මෙතන හිටියේ මේ CO NH 5 times OH කියලා මෙතන මේ ප්ලස් එක විතරක් iron එක විතරක් හිටියේ නම් අනිවාර්යෙන් අයන් ටර්ම් එක ලියන්න ඕනේ. දැන් කම්පවුන්ඩ් එකක් නේ. ඒකට අයන් කැලේ ලියන්නේ. හරි. right. හරි වැඩි කරමු. ලියමු එහෙනම්. කොහොමද ලියන්නේ? හරි. let's start. Ligands in alphabetical order. Amine is there. This OH. OH is there. So this is amine. This is the negative ligand. OH minus. Negative ligands, how to name those? Naming the negative ligands are very easy. Actually what you need to do is just put that O instead of E at the normal name. If it is chloride, Cl minus, as a ligand it is chloride O. Omit the E and put the O. Chloride nang chloride O, you know. So bromide nang bromide O. Negative ligands name කරන්න lazy. Normal name එකම ගත්තා E අකුරු ගැපුවා O දැම්මා. Hydroxide නම් hydroxide O. Omit the E and put the O. Very easy to name the negative ligands. Omit the E of the normal name and substitute it with the O. Hydroxide, hydroxide O. Chloride, chloride O. Sulfate, sulfate O. Omit the E and put the O, right? Okay. So this is then hydroxide, this is amine. A comes first. Amine, A comes first. So 5 of amines are there. Pentaamine. Pentaamine. So no spaces there. No spaces there. Sorry. To insert no spaces there. This space nahi koi baat. Pentaamine. Pentaamine. Hare pentaamine. ඊට පස්සේ OH ligand, that is hydroxide. Only one is there, no? So monohydroxide ලියන්න ඕනේ නැහැ. ඒකට වඩා වැඩියෙන් තියෙනවා තමයි මේ term එක දාන්නේ. pentaamine පහක් තියෙන. hydroxide. Negative ligand, no? Omit the E and put the O. Hydroxide. Then central metal ion. Right? That is cobalt. Just the English name, right? Cobalt. When you are referring to cationic complexes, just the English name you are coming up with. If you are dealing with anionic ligands only, you have to come up with that 8 term, and if Latin name is available, you have to use that thing. If you are dealing with a negative complex, right? For positive complex, yes, for positive complex, this is a positive cation. Cation means positive. Positive complex, just the name of the metal, the English name, right? Cobalt. Hare. Then the oxygen state. How to come up with the oxygen state? So amine thing carries 0. OH minus, no, minus 1 is there. This is NO2 minus. NO2 minus means minus 1 is there. NO2 minus, that is iron, no? So what is the value here? The summation of oxygen state should be equal to the net value, right? So net value is 0. This is a compound. Summation should be equal to 0. So minus 1 here, minus 2 here, 0 here. So this should be plus 2 to come up with 0. Right? Unless you want. May I minus 1 represented now? NO2 minus 2. OH minus 1 represented now? NH3 is without a charge. So minus 2 from these guys. So this should be plus 2. As this is a compound, then the number should be equal to 0, the summation, right? Cobalt plus 2. So oxygen state is plus 2. So just write within brackets 2. Cobalt 2. No spaces, huh? Space තියන්න එපා. Finally, this simple anion. This is just a simple anion, right? Simple anion. I can name what is that? NO2 minus. NO2 minus is what? Right? Nitrite. Right? Nitrate. Sulfate. High oxygen state comes up with 8 term. Low oxygen state comes up with ITE term. Sulfate. Like that. Nitrite. This nitrite. After a space, you write nitrite. That is the answer. So do you have such answer? You should have a space, right, between the catanana and anna vinkarandan space at the unknown air space at the end. So do we have such answer? Pentamine hydroxide cobalt 3 nitride. So answer is answer number 3. But remember, you are not expected to come up with any capital letters, right? All the IUPAC nomenclature should be written in simple letters, right? So podi වැරද්දක් තියෙනවා. paper එකේ තියෙන capital එහෙම බෑ. Organic ගත්තත් inorganic ගත්තත් IUPAC nomenclature හැම එකක්ම simple letters වලින් යන්න ඕනේ. Right? Even you have to start with a simple letter. All the IUPAC nomenclature should be written in completely in simple letters. Right? So the answer is answer number 3. Right? Let's come up with the 9th question. Question number 9. Column question number 9 here. Some organic stuff, ne? Fun. Organic කතාවක් තියෙයි. Right? Done. Ne? Question number 9. Right. Number 9. See what they are saying. So some reaction scheme is given. Right, what is the scheme? Some ring is there. CH2, CH2, NH2. Some NH2 is there. Yeah, and some NH2 here as well. Then they are adding Na into HCl. This thing to come up with A, compound A. After that, adding concentrate H2SO4, then heating, that will give you the B. After that, the Br2 aqueous. That will give you the C. Right? Let's try to come up with C there, no? Which are not the following is suitable for product C. Hurry. Then C ගන්න තමයි තියෙන්නේ. බලමු කොහොමද යන්නේ කියලා. Ready? අපි compound එකකින් ලියමු. හරි මුලින්ම. හරිද? Na into HCl. What this reagent do? මොකද්ද මෙයා කරන්නේ? Na into HCl කියන එක. That is used to convert the OH group to, sorry, NH2 group to OH. This reagent is used to convert the your NO2 group to OH group at room temperature. That is the usage, right? Okay. OH group to NH2 group पे OH करना reagent था वही कथा करना तो ये N into HCl the HNO2 acid, right? Okay. हाँ रे ये ना हम को देने A की निकलना कोई और की नहीं देना विन नॉन. So A should be, this NH2 should be converted to OHs. हाँ रे NH2 को OH वाले convert करना. මේක රත් බැලෙන්නේ කළු එකකින් ඒක එක මෙහෙම කෙනෙක් ඉන්නවා හරි OH ඊට පස්සේ HONK H2SO4 To do what kind of stuff it is used to? Conquer H2SO4 and heating. The dehydrating agent, no? For the dehydration. What? For the dehydration. So, right? Convert the alcohols to alkenes. Convert the alcohols to alkenes by a dehydration. That is the usage of this thing. Right? Converting ROH to alkenes. Dehydration. Right? So, you have here, you have such alcoholic stuff here. Right? Not the phenolic things, right? Phenols වලින් හදන්න බෑ only aliphatic ROH. This is ROH, right? Not the phenol, this is alcohols, right? Okay, so the B should be then. So these things appear like this, no worries with that. But to this point, this OH goes with one of the hydrogen here, right? So you will get the double bond there. You get the double bond there. This OH will release with one of the hydrogen here. So H2 molecule leaves, so double bond will form. Right? That is B. Then what is C? Br2. Br2 is used just to add some Br2 molecules to alkenes or alkynes. Right? So add some Br2 molecules to alkenes or alkynes. So that is one usage, adding Br2 molecules to alkenes or alkynes. Right? That is one usage. We have to few usages, right? We'll first discuss those things, right? First, the Br2 will do this kind of stuff. Some Br as well as here. Instead of double bonds, two Brs will connect. That is one thing done by the Br2. What is the other thing? Just two things are possible. Right? Two things are possible. One thing is this is normal stuff, right? So the Br2, one thing it does is converting carbon-carbon double bonds, so carbon-carbon triple bonds to RBRs, alkyl halides. It is one thing that is it does, right? What else? We can use the Br2s to form tribromo products from aniline and phenol. Aniline phenol දැම්මට පස්සේ මතකයි නේද? අර මෙහෙම එන්නේ. aniline phenol වගේ කට්ටිය දැම්මට පස්සේ දැන් aniline හරි phenol හරි උම ගත්තට පස්සේ මෙයාට Br2 දාපුවම මොකද වෙන්නේ? අර tribromo product කියන concept එක එන්නේ. මතකයි නේද? Even without any catalyst, you can form this thing. Forming tribromo products from aniline or phenol. මේ phenol and aniline ගෙන් පුළුවන්. හරි? From aniline phenol, aniline or phenol. Tribromo products of aniline or phenol. එහෙනම් ඒ වෙලෙත් වෙනවා. මෙතන සෙට් වෙනවා වගේම. හරි? tribunal product වල තියෙනවා. මේ tribunal product කොහෙද හදින්නේ? ortho para වල. So ortho positions as well as para positions. Ortho para positions. In the ortho para positions, we ortho para 246 fibromphenol. 246 means ortho and para positions. Ortho para positions. You get the tribunal products at the ortho para positions. Right? Ortho again are long positions. Para again directly opposite. Para and two orthos. So this is the answer. Do we have such an answer? Yes. Answer number 3. Answer number 3. So your answer is answer number 3. Alright. This is question number 9. What? Right. Up here, 10th question. Question number 10. Right. Okay. The 10th question. Gaseous state reactant molecule X and Y react with each other to form gaseous product Z. Some reaction is given like this, right? X gas reacting with Y gas to produce Z gas. Gaseous state reaction is given. The following table contains the concentration of X and Y with the rate of formation of Z. Okay. When the concentration of Z, X, Y, Z numbers are given, what is the rate of formation of Z? That is what they are asking. What is the rate of formation of Z? Right? Okay. So to come up with the rate of formation of Z, right? We need to come up with the rate of the reaction. If you can come up with the rate of the reaction, then rate of formation of Z can be calculated because rate of the reaction and the rate of formation of Z is with 1:1 ratio. When one reaction occurs, 1 times the reaction occurs, 1 of Z gas will produce. So rate of formation of Z gas is equal to the rate of reaction, right? So first of all, we need to come up with the rate of reaction. For that, we need to come up with the rate law. So rate of reaction can be calculated with the use of rate law, with the use of concentrations of the reactants, if you know the rate law. If you know the rate law, if you know the values of these X and Y, if you know the values of these orders, I'll put as A and B. So A and B and X and X and if you know these values, we explain some in A and B. If you know the respective orders, by substituting to these numbers, you can come up with the rate, right? Okay. So that is what we are expecting here. Right, first of all, let's try to come up with the order. For me, A value ko hoyaganna modu ganna oni. A value ko hoyaganna mulin B value. What is it? Easy. Yes, the coming up with the B value is easy. Right, coming up with the B value is easy. Solving for B. Right. So let's consider the experiment 2 and 3. MCQ නිසා ටක් ගාලා හදනවා. MCQ නිසා ඔක්කොම ලියවි ඉන්නේ. හරි. Let's consider the experiment 2 and 3 to come up with the B value. To come up with the B value, what you need to do is just take 2 experiments with, right, equal concentration for the other species. If you need to come up with the B value, what was the just take two experiments with same concentrations for other species. And it cut here take reactions they consider. right. එතකොට එනවා see you can take the exponent 2 and 3. What I am doing is just divide 3 by 2. That will give you the rates, will give you 6.4 into 10 to the power minus 3. For the 2 it is 1.6 into 10 to the power minus 3. The proportionality signs will cancel off, is equal to k will cancel off, right? Okay, for these values 0.4, these will cancel off because both the x values coming up as 0.6, right? So I'm just substituting the y values like this, no? Alright, well, my x values cancel off, මම 3යි 2යි කන්සිඩර් කරනවා පස්සේ x values දෙකටම එන්නේ 0.6 කියලා. ඒක cancel off වෙනවා. හරි. එතකොට y value is 0, right? So this looks like these things will cancel off. So 4 is there and this is just 2b. So 2 to the power 2 is 2b. So b is equal to 2. හරි එකක් හරි. Right? 2 is b is equal to 2, right? Now let's solve for a as well. ඒව solve කරන්න ඕනේ. ඒව solve කරන්න කියලා තමයි y ගේ constraints දෙකක් සමාන exponents දෙකක් වර නැහැ. ඒක වොරි වෙන්න එපා ඉදියකට. හරි, ඒ වොරි වෙන්න ඕනෙත් නැහැ ඉතින්. හරි, මොකද අපි කරන්නේ? හරි. එක substitute කරන්න මෙහෙම. හරි. So solving for v. එහෙම මේ y ගන්නේ සමාන මේ දෙකක් නැහැ කියලා බය වෙන්න එපා. මෙහෙම කරන්න නිකන් කරන්න. හරි. ඔන්න බලන්න මේ වැඩි කරන්න හැටි. හරි, let's take the 2 and 1 and 2. 1 and 2 select කරන්නකෝ. හරි, 1 and 2. I'll take the 2 divided by 1. මේ බලන්න වැඩි කරන්න හැටි. y values නැතුණා කියලා බය වෙන්න සමාන නැහැ කියලා බය වෙන්න එපා. හරි. එතකොට මේ ඔයාලට එනවා 1.6 into 10 to the power minus the rates, right? 3 divided by the 1 means this if you are taking it to 10 to the power minus 3, it is 0.4, right? 10 to the power minus 3 වලට ගත්තොත් 0.4 වෙනවා. 4 තියෙන්නේ හරි. 10 minus 3 වලට ගත්තා හරි. 4 තියෙන්නේ 3 වලට ගත්තා. Is equal to k values will cancel off. The a values 0.6 තියෙනවා, 0.3 තියෙනවා as a values. This is the power a, and as y values මේ x values ටික මේ y values විදිහට ඉන්නවාට 0.4 and 0.2 power b. හරිද? හැබැයි මේ b එක විදිහෙන් දාන්නෝ. මේ b එක දාන්නෝ. අපි හෙව්වොත් this 2. No that trick එක හරි. බය වෙන්න එපා. මේ ආ values සමාන දෙකක් තිබ්බේ නැහැ කියලා බය වෙන්න ඕනේ අපි. හරි. right. So මේ කැපිලා යනවා. So ඔඩෙනවා this 4 is equal to මෙතනින් එනවාට 2 කියලා නෝනේ 2 to the power a is 2. මෙතන එනවා 2 to the power 2 2 to the power 2 2 to the power 2 is 4 2 to the power 2 is 4. It's just 2 2 to the power 2 is 4. The 4 will cancel off. So this is just 1 is equal to 2 to the power a. That means 1 කියලා කියන්නේ මොකද්ද? ඕන මේක 0th power එක. Alright. So your rate law comes as k into what a is known, right? So y gas into 2. This is your rate law. Then मैं apply करना थी. ये apply करने के लिए k वाला दान है. You don't know the k वाला दान थी सा. इस बाय वेन्ने पा. k वाला दान तो बाय वेन्ने पा. अब मुझे ना नहीं. आप experience दिया गम. Experience दिया करम बेदूँ. तो कि type नो. Right? Consider the fourth reaction as the thing they have related. हरी? ये वाला relate कर भी fourth reaction निकले गाना बालूं. ये वाला मैं ही मुकम. तो अभी गमू new reaction. हरी? New reaction divided by यहाँ पे काउंटर एक ओने अगन divided by 1 क्या होगा 1 new reaction divided by 1 हरी और है ना वहाँ हरी rate new एक है new reaction divided by 1 1 එකේ rate එක 4 into minus 4 සමාන වෙනවා k එක කැපිලා යනවා නේද k එක කැපිලා යනවා y එක new reaction එකේ y එක දීලා තියෙනවා 1.2 කියලා හරි එතකොට one reaction number 1 එකේ y එක එනවා 0.2 කියලා නේ ඒකේ power 2 කොහොමද මට 6 කියලා එනවා 6 to the power 2 වෙනවා මේකෙන් වට එනවා හරි r new ඉන්නවා some 4 into the power 4 ඉන්නවා මෙතන 6 කියලා 6 to the power 2 is 36 so වට එනවා 36 into 4 is 120 එනවා ඊට පස්සේ හයක් නේ 148 නේ 148 the r new coming up as 148 that means 1.48 into 10 to the power minus 2 mole dm minus 3 is minus 1 sorry 144 is 144 72 and 144 right you home එනවා නේ හරි ඒ බයෙන් යන්න යනවා ඒ කියන්නේ මේකට සබ්ස්ටිටියුට් කරන්න කේව දන්නේ නැහැ කියලා වොරි වෙන්න එපා කේව දන්නේ නැහැ කියලා වොරි වෙන්න එපා ආයෙත් රියැක්ෂන් දෙකක් කන්සිඩර් කරන්න නිව් එකයි අපිට අවශ්‍ය එකයි දන්නේ ඒක විතර කේ කැපිලා යනවා ඒතර ඔර නිව් රේට් එකේ හරි ඉතින් මේක තමයි as these two guys are with 1 to 1 ratio so rate of production of Z is actually equal to the rate of reaction 1 to 1 ratio 1 to 1 so it is equal to 1.44 into 10 to the power minus 2 right you home the answer is answer number 1 your answer is answer number 1 right 18th question එක හරිනේ එහෙනම් අපි අදට මෙතන නවතිමු right අපේ online session එකේදී අපි essay question එක essay paper එක අපි review කරමු right හරි එහෙනම් goodbye then see you next week